More on bond pricing. Uh, you know, Prices fall as interest rates rise. Prices are going to increase as interest rates fall. The inverse relationship. They Interest rate fluctuations are the primary source of bond market risk. For example, the Fed's recent interest rate increases over the past couple of years have certainly increased rates in the short to intermediate term. This has created uncertainty in the bond market. Um, More recently, the Fed decided not to raise interest rates. The And this decision was received favorably by the bond market. Uh, the Bonds with longer maturities are more sensitive to fluctuations in interest rate. Hopefully this makes sense. The longer your present valuing and cash flow, the less it's going to be worth, or the more sensitive it's going to be, the more it's going to fluctuate. So the figure 10.3 shows $1,000 bond. It's an 8% coupon 30-year bond. So we start out at 8% at par. So at the 8% bond, interest rate goes to 10%. The value of that bond is going to drop to $810.71. So the opposite would happen if interest rates were 10% and we had held this 8% 30-year bond and rates fell to 8%, the value would increase to par. Table 10.2 shows 4 different maturities for bonds: 1 year, 10-year, 20, and 30 years. And the top line here is market interest rates. We've got all of our bonds are 8% bonds. So at 8%, they're par bonds. When on the 1 year bond, when the rate goes to 10%, the price only falls to $981.41. And our bond from the chart, we saw that price fell to $810.71. We can also see that the appreciation is much greater for a 30-year bond than it is a 1 year bond. So if we go from 8 to 6%, the value of that 30-year bond goes up $276.76 versus $19 for that 1 year bond. So mentioned this before, bond pricing between coupon dates is the invoice price. The book calls the price of the bond the flat price. So invoice price is the flat price plus accrued interest. We have to allow for accrued interest between interest payment dates, which accounts for the vast majority of bond trades, because the interest payment dates are only 2 days a year, and there are 250 trading days during a year. So 248 days out of the year, there's going to be accrued interest. You can do bond pricing in Excel, as I mentioned. The function is equals price, the settlement date, maturity date, annual coupon rate, yield to maturity, redemption value, as a percent of par value, the number of coupon payments per year. You can also specify in Excel whether you want to do your calculation on an actual or 360-day basis, as we talked about. I recommend you learn how to do it in your calculator. However, if you want to use Excel, that's fine too. This is what an Excel spreadsheet. I'm not going to teach Excel. I'm going to do examples on bonds using the calculator. So bond yields. Yield to maturity is the discount rate that makes the market value, the present value of the bond's payment equal to the price. So the current yield is annual coupon divided by bond price. The one thing to note about current yield is always going to fall between the yield to maturity and the coupon rate. So if the yield is above the coupon rate, then the current yield is going to be lower. If the yield is below the coupon rate, then the current yield is going to be between it. So it's not an accurate measure. It's just something to give you an estimation. The premium bonds are bonds selling above par value. So if the yield to maturity is below the coupon rate, that would be we would have a premium bond. If a discount bond is bonds selling below par value, so yield to maturity greater than the coupon. You can find yield to maturity in Excel. The formula shown here. You know, again, I'm not going to teach Excel, but it's shown, and you can certainly use it if you choose to. Yield to call is calculated very much like the yield to maturity, except it's calculated till the time to call is the call date is replaces maturity, and the call price replaces the par value. I will work some examples or in some of my lectures where we do yield to call calculations. Premium bonds are more likely to be called than discount bonds. The reason being that interest rates have fallen, and the issuer can refinance that debt and issue bonds at a lower rate. Example here, we've got a graph where we have the bond price and the interest rate, bond price on the y-axis and interest rate on the x-axis. We saw the straight bond price before, so it has a curve to it. And however, if the bond's callable, there will be a ceiling for the price. Buyers will not be willing to pay over that call price. So the price function will look much different for a callable bond.